Hello, my name is Isabel Hasty, and this is my final project for the Big Data Processing Using Hadoop course, which is on Scoop. This is an introduction to Scoop. First, a bit of motivation. Scoop is great if your data is stored in a relational database system. Say you have a ton of data, and that data already has a home, and that home is a relational database. Then you can use Scoop to bring it into HDFS and do some processing on it. Furthermore, if you want your output to be stored in a relational database, say you have a bunch of data, it can originate from HDFS or Hive or somewhere, but you want that output to be stored in a relational database, again, you can use Scoop, and it'll provide that import export capability to and from a relational database. So what is Scoop, and how does Scoop accomplish this? Scoop, as I mentioned, is a tool for transferring data between Apache Hadoop and a relational database system. This can be any traditional type of relational database, MySQL, PostgreSQL, Oracle, that type of thing. And the way it does transfer back and forth between Hadoop and relational databases is to initiate a MapReduce job. So what it does is you use Scoop. It's a command line tool. You type in your command to import or export, and Scoop will translate that to a MapReduce job, and then your data will be nicely imported or exported into or from HDFS. One little note here, there are two versions of Scoop. Like Hadoop, there is a Scoop 1 and a Scoop 2. And Scoop 2 was an effort to address some of the limitations of Scoop 1. So I mentioned that Scoop 1 is a command line tool. It's not much more than a command line tool as of this moment. So Scoop 2 brings in a really nice Java API to facilitate some of those conversions outside of that command line. Scoop 2 is not compatible with Scoop 1. That's an error on the slide. Scoop 2 is command line interface is not compatible with the Scoop 1 command line interface. That means that the commands are different. And as Scoop 1 is the current stable release of Scoop, and Scoop 2 is in active development, I've chosen to use Scoop 1 and do my demonstration using, I installed and show you how to use Scoop 1. A couple Scoop commands here. So if you go into Scoop and you type Scoop help, it is really nice. It gives you this nice list of commands here, and the just a little description of what it can do. So you can use the code gen command to generate code that interfaces with the database records. You can create a Hive table from to import a table definition into Hive. You can use the eval command to evaluate a SQL query and show the results in HDFS. You can use export. This is so I'll show how to use the export command actually, and this is to export an HDFS directory to a table into a database, a SQL database or any type of database. The help command is what I typed in to get this lovely menu. It will list all of the available commands. The import command will import a table from a database to HDFS, and I will have a hands-on demo that shows the functionality there, just how to do that. Import all tables, very similar to import. Instead of specifying one table, import all tables will import all the tables in a particular database. Import mainframe will import from a mainframe. It's pretty self-explanatory there. Job will work with a saved job. You have the capability of saving some jobs and doing some work on those. List databases, just like in SQL, you can list all databases on a server. Instead of show databases, it's list dash databases. List tables, same thing. You can merge results of incremental imports. So if you import part of a table and then another part, you can merge those together. Metastore will run a standalone Scoop metastore, and version just displays the version information for the particular Scoop version or implementation that you are currently using. One note here on Scoop connectors. So Scoop is a framework. It is an extension framework, which makes it really flexible. With Scoop, you have the ability to connect to any type of database. It's really nice that way. And what you need in order to connect to those databases is to have the correct Scoop connector. So a Scoop connector utilizes the Scoop framework and enables the inputs and outputs to and from SQL and HDFS. So Scoop by itself ships with some default connectors. You can see I've listed them here: MySQL, Postgres, Oracle. And then in addition to those connectors that are already shipped with Scoop, there is also a generic JDBC connector that enables connections to any database that supports Java's JDBC protocol. So that's really nice because it's really flexible. So in my demo, I've found this JDBC connector, downloaded it off the internet, put it in the right spot, and I'll show you where that is and how I've gotten this connector to work with Scoop. A couple of references here. I borrowed heavily from scoop.apache.com. There's a great documentation there. And I've also used the book Hadoop, the Definitive Guide by Tom White. And of course, I've done quite a bit of Googling and gotten some answers from Stack Overflow. Alrighty, so now I will switch over and show you a little hands-on demo. Okay. So first, what I did was I went and downloaded Scoop, and that was very easy. I went to scoop.apache.org. In this releases section, I went to Scoop 1, as I mentioned, and the latest version of Scoop is 1.4.6. There is a good amount of mirrors here, and so I just picked the first one. And then you have a couple different options, a couple of binaries here. The one you want to use is for Hadoop 2. We've been using Hadoop Yarn, so we want to use the Hadoop 2 version. So I went ahead and I downloaded this guy. And I went and I untarred it and I put it in user local Hadoop. So you can see here, you can see that first I downloaded the -1 version. This did not work. If you do this, you get a lovely incompatible class change error exception. So I still have it here, but I'll show you that my setup is using this Scoop 1.4.6 Hadoop 2 version. Okay, so once you download that, you can go into the Scoop folder. And then if you go into this conf directory, it ships with the scoop env template.sh. And what you can do with that is copy that in as so just do cp scoop env template to scoop env.sh, and then you copy it over. I already did it, so I'm not going to do it again. And then you want to set your environment variables in scoop env.sh. So I've already gone ahead and done that here. Pretty simple. You want to set your Hadoop common home environment variable to wherever it is that you have Hadoop installed. For us, that's user local Hadoop /Hadoop 2.7.2. It's the same thing for Hadoop map-read home. Again, user local Hadoop 2.7.2. And then I put in HBase. I put in the environment variable for HBase as well, which is user local Hadoop HBase 1.2.4. And then I didn't set the Hive or the Zookeeper ones just because I don't use those in this demonstration. But if you were to use those, you wanted to use Scoop with Hive or Zookeeper, then you want to make sure to set those environment variables here. Okay, so that is the conf. The configurations for Scoop. What we want to do next is I just want to show you that I have set my path variables and stuff. So actually, let's show you my bash profile. All right, so I've added this line here, export Scoop home, and so this is where I wanted to show you that I am using the Hadoop -2.0.4 version, not the -1. And I've set that to my Scoop home. And then also I've added it to my path right here. And one way to make sure this is working, actually maybe I should source it, is to type Scoop. And if you've got it working, then it will, well, it doesn't do a whole lot right now, actually. Right now it's telling me that I have not set my hcatalog environment variable or accumulo or Zookeeper. I knew that. I don't plan to use those here. So I'm not really too worried about those error messages. But if I did want to use those, then I would want to make sure to set those in my in the configuration file, the scoopenv.sh that I showed you before. So it didn't do anything. Well, it didn't do much when I typed in Scoop. So let's see what happens when I type Scoop help. There is my list of commands that I've shown you before. So by this popping up, I know that my Scoop is configured properly. I know that my environment variables are set properly, and I am ready to go to use Scoop. Another really nice functionality is that, you know, I typed Scoop help. I can also do Scoop help and then any number of these available commands. So if I want more information on the import command, then I can do Scoop help import. And Scoop will tell me all sorts of stuff about, whoops, oh, okay, whoops, come on. Okay, Scoop will tell me all sorts of stuff about the import command. So you can see here, it's telling me what my options are and what I can set and kind of specify here. So all my arguments. Okay, so now I have set up and installed and configured Scoop. Now, of course, Scoop also depends on, or well, if you want Scoop, then it's probably because you have some sort of relational database. So for my purposes, I needed to install a relational database on my VM here. I chose to install MySQL. And to do that, I went into root. Our password is what we set it up as. And so yeah, if you want to install MySQL, it's really easy. You can just do sudo yum install MySQL server. You can go ahead and run that command. I'm not going to do it here because I already have. But one thing, okay, so yeah, so you go ahead, you install it, and then you want to start it. And to start it, you do sudo service MySQL d start. And then that will start your SQL database. Yeah. So you need to do those two things, which for me are already done, which is quite nice. Let me see here. Yeah. I think you can also do sudo service MySQL status, maybe? There's a way to get the status. Oh, MySQL D, right? Okay, there we go. So there is a way to show the status of that MySQL database. And so running sudo service MySQLd status is just showing you here that I've got a SQL database, it's installed, and it's running. Okay, so I also want to, so I want to, just for our purposes here, I'm going to create a database. So I will do MySQL -u root p. It's asking me for a password. I didn't set up a password, so I just hit enter. So, and now it's giving me the MySQL command line. And all right, so I'm just going to create a fun dummy example here. We're going to do create database. Oops, database. We're going to call it hadoop test. And so while I'm here, I also want to grant all privileges on hadoop test dot star to localhost. So I think, oops, you need a semicolon. Okay, that's not working. We're gonna try that again. Oh man. Grant all privileges on hadoop test.star, so all of the tables in hadoop test to, I think, oh, whoops. There. Okay. All right, good. So I have a database, it's called Hadoop Test, and all of my users can access and modify and read Hadoop Test. So that's all I want to do from here. It says bye, it's very nice. So now that I am back to, actually I want to quit this too. Oops, or maybe exit. Yeah, okay. So now that I'm back to HD admin, I can go into my Hadoop Test database and just make some dummy data, put some dummy data in there so that then I can show you how to bring that database or that database table into HDFS. So I'm going to do MySQL Hadoop test. Oh man, there. And then I'm just going to create a table. Oops, create table. I'm going to call it students. And it's going to have an ID, which is an integer. I'm going to tell it not null. I'm going to say it's the primary key. And I'm going to auto increment it. You don't really have to do all this. Increment. But it's kind of good practice. So a student has an ID. A student is also going to have a first name. First name. We're going to call it varchar 64 maybe. Yeah. And last name. And a graduation year. Just for our purposes to show how this works. Okay, so now I can do show tables. Oops. And then you can see that I have one table and it's called students. If I do select all from students, you can see that it's empty. So let's put some stuff in there. So we're going to insert into students values null, so I don't have to specify the ID because I said that it's auto increment there, so it'll and not null, so it will do that for me. So let's insert Homer Simpson. And let's say Homer Simpson graduated in 2004. Oops. What did I do wrong? Insert into students. Oh, oops. Yeah, I did that wrong. I'm not good with the quotation marks today. that needs a quotation mark. Okay, so I put Homer Simpson in. Let's say we also want to put Ned Flanders. Oh, who I guess also graduated in 2004. And let's do Mr. Burns, who graduated in like 1960. And one last one. Let's do Krusty the Clown. Krusty Clown. And let's 1990. Why not? Okay. So now if I select all from students, you can see that I have 4 different entries in my students table. They have IDs of 1 through 4. They have first names, they have last names, and graduation year. Okay, so I just really quickly made a database in MySQL. I created a table called students, and what I'm going to do now is show you how to import that students table into HDFS. Oh, one thing I forgot. Okay, so in order to import into HDFS, as I mentioned, you need those JDBC connectors, or, well, you need a connector. And the truth is that the MySQL connector already shipped standard with Scoop, but I wanted to show how it works with the generic JDBC connector. So I'm going to go just show you what that looks like. So cd user local hadoop scoop 2. Okay, so in order to use a new connector, you need to put it into the lib folder. Not the lib folder. Okay, so you can see here that, so all of these great jar files came, excuse me, with, oops, okay, came with the distribution of Scoop, except for this MySQL connector, which I downloaded. I think I just Googled it. Yeah, I think I just Googled JDBC connector Scoop, and I got the tarball, and I untarred it into this folder. You can see what it looks like. I had to move. So this is all the stuff that came with it. And then I copied that jar file into the lib folder because it wasn't working nested like that. So it had to be right there in that lib folder. And that just adds it to the path. That's all. Okay, so that connector's there. So now I can show you how to import stuff into Scoop. So let me just show you my JPS command. I just want to show you that I have all this good stuff running, Node Manager, my data node, my name node, my job history server, and my resource manager, which I need for HDFS and therefore for Scoop. So, all right, so my Scoop command is Scoop import. Actually, I'm just going to go back here so it's nice and clean. Okay, so I'm Scoop help import, right? So, just going through some of these options here. I am going to specify a couple of different things. So the first thing is the connection, and there's the URI, and so I have to specify what my connection is, and in that same spot you specify the database name. So I'm going to use that connect argument. I am also going to use a couple other things that I wanted to show you here. Num mappers. So I mentioned that when you kick off or when you submit a Scoop command, it turns it into a map reduced job. So using that M command, you can change the number of mappers that are used. If you use more than one mapper, you'll get more than one output, of course. So I'll just specify that as one. The table argument specifies what table you're bringing into HDFS. And I think those are actually all the commands that I'm going to use, but there is a ton of other good stuff here. So I'm going to do scoop import. Like I said, I'm going to use the connect. It's jdbc colon MySQL colon / / localhost / hadoop test. So that specifies my connector and the database name, which is Hadoop test. I'm also going to say that I want, table students. And I'm going to specify that I only want one mapper. So kick it off. I get my 3 error commands or warnings, I guess. And you can see it is kicking off a MapReduce job. My VM can be a little bit slow. I should probably have shown you that there's nothing there first. I wonder if I can still do that. If I can beat it to it. Nope. Oh well. So what I wanted to show was that before I did this, there was no students. But as you can see, now that I have kicked off the MapReduce job, there is a folder called students right here in HDFS. It's under user HD admin. And yeah, there it is. So I can show you what's in that folder. And you can tell that I just made it because we have today's date, December 16th, and the time, which is 6:42. So I just made that. And if that had already been there, actually I can just show you right now, it'll crash because it does not like it if there's already a folder. Yeah, so there we go. See, here's my error showing me, yep, output directory already exists. So that's what you get if it already exists. Okay, so user HD admin students. Okay, should look familiar. We have a success indication here, and then the contents of our result. And I can do a cat here to show user HD admin students part whatever --. And voila, very simple. We have shown that we have successfully brought our data from a SQL database into HDFS. One other thing I can show here is the job history server. And I just wanted to show that this is my job. And so, like I mentioned, it created a MapReduce job, well, with the one mapper, and it was successful. So this is just the details there in my job history server. Okay, so I have shown you just a really quick demonstration for how to install and configure Scoop and how to install a MySQL server and how to just bring a really quick, easy, simple table into HDFS. Okay, so another part of this, maybe, no. Okay, another part of this was to show how to solve a particular problem using the technology at hand, in this case, Scoop. So, so my problem that I've chosen is, say, hypothetically, you have a MapReduce function that you have already written. You spent a lot of time, MapReduce can be challenging, so you've debugged it and you are confident that this particular MapReduce function works. So you want to use that. You want to take advantage of that MapReduce function, but your data is in a SQL database. So the solution in this case is to use Scoop to import the data into HDFS. Then you can use that MapReduce function that you work so hard on. And finally, you can use Scoop once again to export the results back from HDFS into your SQL database. So I'm going to show a little demo for how to do that. Okay. So first, I just want to show you, as I mentioned, we have a so we have a bunch of data, and it's already in MySQL. So if I do show databases, you can see we have the Hadoop test database that I just made, and we also have this movie ratings database. This is something I created ahead of time, and it should look very familiar because it is the data that we have used throughout this course. So let's see here. I will go and use movie ratings. Database changed, and then I can show tables. And as you can see, I have two tables, movie data and rating data. Again, should be very familiar. And I'm just going to show you, select star from movie, let's start with rating data. Rating data should look very familiar. This is a tab delimited file. Well, okay, no, actually, this is in a SQL table. So it is, can I describe rating data? Yeah. So we have 4 different fields: user ID, movie ID, rating, and time. User ID, movie ID, and rating are all integers, and time is a big integer. And as you recall, user ID is a particular user, movie ID is a particular movie, and rating is the rating associated with that user given to that movie. So then if I do the same thing for describe movie data, again, should be very familiar. There is a number of fields: movie ID, movie title, date, unknown, IMDb URL, and then a whole bunch of different what are those genres that the movies can be. So again, I will select star. This one might be ugly. From movie data. It is ugly. Let's actually just select movie ID, movie title from movie data. Okay, it's still kind of ugly. We're going to limit it. Limit 20. Okay, so you get the gist. I just want to show you that this really is the movie lens data that we've been working with all semester long. And all I did was bring it into a MySQL database in 2 tables. So as I mentioned, we have already defined a MapReduce job or a MapReduce code that we want to leverage here. So in order to leverage that MapReduce programming code, I want to import my data from SQL into HDFS. So like I showed before, we can use a scoop import to do that. Again, my connect argument is jdbc : MySQL : / localhost. In this case, it's movie data. We're going to start, it's movie ratings, right? Yeah. So I want to import, we're going to do it one table at a time, just to, there's a reason I'm doing that. As you recall, the delimiters for the 2 files were different. So I want to import one table at a time so that I can specify the delimiters as I bring it into HDFS. So the table I want to do first is rating data, just because it's a little bit more simple. Is it called movie ratings? Yes. No, it's rating data. Rating data. Well, we'll see if it works. I want to specify just one mapper. And then, as I said, I want to specify the the delimiter. So I'm going to do feels terminated by, and I want it to be a tab. I'm just doing that because for this particular data, it was tab delimited to begin with, and actually my MapReduce job that I want to use depends on that, because that was written specifically for the movie lens data that we had brought into HDFS to begin with. So that's why. Okay, look like it's working. It's kicking off a MapReduce job to bring my data into HDFS. I should be able to go into my job history. And, oh, not yet. Okay, well, it will show up. Hasn't done anything yet. Okay, so it finished the import. So let me show you what that looks like on HDFS. Hadoop fs-ls, and again it goes under user hd admin. So now I have students, which I got before, and this new rating data. So let's look at that, make sure it imported properly. Hadoop fs cat user hd admin students. No, rating data. Okay, I did that wrong. Remember that rating data is a folder, and in the folder there's a success and the part file. So I should have done the cat on the part file. Oh no, I've done this before. I used the wrong, okay, hold on. We're gonna do Hadoop fsrmr user hd admin rating data, right? Okay, I'm gonna have to do it again. Sorry guys. I escaped it incorrectly, which is a silly mistake that I've made before. I'll get ready here. Hadoop fs-ls user hd admin. I'm just waiting. Okay, it's done. Okay, so I have rating data again, and yeah, so that just got created. So then let me do the cat again. Bam. Okay, it's right that time. There is the data that we had in MySQL, lovely in HDFS in the format that we wanted, tab delimited. So that is the rating data. Remember that there was also the movie data, which was a little bit uglier. Movie data. So it's the same import command. The database and connection is the same. Again, I just want one mapper because I just want it to be all together in one file. But the what is it? The delimiter is a pipe. So I'm going to go ahead and bring it in. Okay. now we have movie data in addition to rating data. So let's cat hadoop fs cat user hd admin movie data p star. Okay, should look really familiar. That is exactly the movie data that we had before. Okay, so I'm just gonna clean it up a little bit so that we can use the previously created MapReduce jar from one of our homework assignments. So I'm just gonna hadoop, I'm gonna make a directory. Actually, maybe I should, let's see what we got here. Okay, so I'm gonna make a directory called, I'm gonna call it movie data. Why not? Okay, and then I'm just gonna move the two files I just created. So user hd admin, we'll do movie data, and we will call that, we'll put it in movie, okay, well, that's a little misleading, but that's okay. So our movie data is the specific data about the movies, and it is in a folder called movie data, which is all of the data about the movies, but that's okay. So we'll put it in movie data, and remember that it was called u.item. So I moved it. Now I'm going to take the rating data and move it into directory movie data, and I'm going to change the name to u.data. So now if I list the directory movie data, it has two items, u.data and u.item. Just to be safe, I'm going to, well, let's just make 100% sure that worked. Oh, you know what I did? That's silly. Okay. I'm sorry about that. So I'm going to make a new one. Hadoop fs make dir. I'm going to call it something better this time, like movie files. And now, when I move it, I want to move, so this is a folder. So what I want to move is part M00000. And I want to move it into movie files now. I just think that's a better name for the directory. Oh, because I already moved it. Darn it. And I removed it. Okay, guys. Sorry. I'm going to have to do this again. That's cool. Okay, so that moved the rating data. I also want to move the movie data again. Okay, let's make sure that worked. Movie data, rating data. Okay, so now I can just use the command movie data part yes. And movie, oh no, rating data is u.data. We're getting there. Okay, so again, I just want to check it. Who knows what mistake I could have made this time. Movie files, u.item. Okay, that looks right. Data. Okay, whew, that looks good. Okay, so for our purposes, I am just going to use a jar that we already created for one of our homeworks, but remember that the problem statement is you have something that you've created and you want to use that thing, and that's why and that thing is based off of MapReduce in our case. So that's why we wanted to bring everything into HDFS. So I'm just going to go, I have some NetBeans projects. I'm going to use the movie ratings one. So movie ratings, my dist. So I'm going to use this movie ratings jar. So I'm going to call yarn jar movie ratings on my movie files. And I'm going to specify an out directory. It's going to be called movie files out. It's going to be called movie statistics. I try to name things fairly well. Okay, so as you can see, my movie ratings jar is calling a MapReduce job. This is, I don't know, I think it's homework 2. It is the one where we used MapReduce to join the two data files, the rating file and the movie file. And the goal was to output a number of statistics on the different movies, what the average rating was, how many users rated it, that type of thing. So that's what's going on here. Looks like the mapper is completed. It's turning. Okay, reducer's done. Cool. So now, if we look, I think I called it movie statistics. Okay, so our MapReduce jar file worked, and we got a success file and a output file. I'm going to show you what that looks like. Cat movie part R, whatever. Okay, so it's kind of ugly here, but here is your ID, your movie ID number, movie name, release date, IMDb URL, and then you have the average number of ratings, or the average rating, then the total number of unique raters, and the total number of ratings. So this movie was rated a 3, and it was rated a 3 by just one person. Okay, so I have this output, and now what I want to do is I want to take this and I want to export it back into my MySQL database, and the way I'm going to do that again is Scoop. So the first thing you have to do is you have to go into your database and set up a table that matches the format of the data that you're going to bring over. So I'm going to go into MySQL, movie ratings, that's because I spelled it wrong. Okay, and then I'm going to create a new table. I'm going to create table movie statistics. I'm I'm going to have a movie ID, which is an integer. I'm going to have a movie title, varchar, it's big, right? So maybe like 100. Movie, what is it, like the release date? Let's just call it release date. Is that next? Yeah. Again, varchar. Well, that's kind of smaller. 50. 64. 64 is a nice number. Now is our IMDb URL. That's really big. Let's call it 512. Our average rating, which is a, let's a decimal. Why not? Unique number of raters, unique, which is just an integer, and then total ratings, which is just an integer also. Oh man. Oops. That's better. Okay, so now if I show tables, I have a new table called movie statistics. And if I select all from movie statistics, it's empty. So what I'm going to do is use Scoop to export what I have in HDFS and bring it into that movie statistics table. So just like Scoop import, it's Scoop export. Same connect JDBC colon the table is the table name over here, so movie statistics. And then I need to specify the export directory, which is movie statistics. Same thing. Movie statistics, and it's part R 1, 2, 3, 4, 5. And then I'm just gonna specify input fields terminated by. I'm just gonna make it a tab because that's what it was for our homework output. The default would be a comma. It doesn't really matter, but for our sake, it really doesn't matter. Oh man, what did I do wrong? Scoop, export, connect, JDB. Oh, I forgot a colon. No, it's fine. Let me see. Scoop, export, connect, JDBC MySQL // localhost movie ratings table. Oh, duh. What is it? Check the mana. You have an error in your SQL syntax. That's not. Oh my gosh. Oops. Silly me. Okay. That's better. In my defense, I am very jet lagged from my 14-hour plane ride. Okay. So what it's doing now is it is kicking off another MapReduce job to bring the data that we had in HDFS back into my MySQL server. and it's going to be placed into the movie statistics table that I just created. Slowly. It's pretty big. My computer's pretty slow. Okay, there we go. So now if we could do MySQL movie. Oh my gosh. I want to show tables. There's that movie statistics. We're going to select star from movie statistics. Bam! Okay, that's pretty ugly. But it is there. Let's do a describe. Describe movie statistics. There we go. That is our table that we've created. So now when I select, I'm just going to select movie ID, movie title, and average rating. Okay, there we go. And you can still do more than that, where movie ID equals, I don't remember, like 375 or so. No, that's not the right one. I don't remember which one was in the homework, but it's very easy to get the average rating for a particular movie using this. Alrighty, so I have shown you, I've given you a short introduction to Scoop. I have shown you how to install and configure Scoop and how to install a MySQL database on your virtual machine. I've shown you how to import data from MySQL to Scoop using the JDBC connector. And I've shown you how to run something, do some sort of operation in HDFS, and then how to export the result of that operation back from HDFS back into MySQL. So that is my project. I hope you enjoyed it, and thank you very much.